So in this video I'm going to go over how to calculate average atomic mass. We'll also recap the definition of an isotope. We'll also answer the big question, why is the average atomic mass from the periodic table, why is it a decimal number? If you want to work out the number of neutrons and you subtract average atomic mass and the atomic number, you end up with a decimal. So why is that? Neutrons are whole particles just like electrons and protons are. So how is it that this can be? Well, we'll hopefully answer that question with this little video. So just to go back to the definition of an isotope, which is very important. An isotope is when you have atoms of the same element that have got different numbers of neutrons. So the number of protons and electrons remains the same. And we actually have an example of oxygen here. All these three different isotopes of oxygen have the same number of electrons, the same number of protons. Another way of saying that is they've all got the same atomic number. So 8 electrons and 8 protons in each one of these. But the number of neutrons is different, 3 separate isotopes. So when it comes to isotopes, all elements have isotopes. Some of the man-made elements, isotopes haven't necessarily been discovered yet. For all the naturally occurring elements, there are isotopes. Some of them are radioactive, so that could mean that they don't exist in nature very long. They actually undergo decay. And then some are stable. So the average atomic mass from the periodic table usually just includes stable isotopes. Okay, so how do we work out the average atomic mass? And that's going to help us understand why the average atomic mass from the periodic table is a decimal and not a whole number. So you can compare this explanation to how your grade is calculated. If you think about, say for example, my chemistry class, you've got 20% is for trimester final, 20% is for responsible action, and then tests and quizzes is 30%, homework is 30%. So you have a weighted average. So your grade at the end of the trimester or the end of the year represents how well you did in each of those, and each of those is worth more, maybe a different amount than something else. A weighted average is the concept that we're learning here. You may have done it in algebra, maybe not. But how your grade gets calculated, it's the exact same approach, the exact same level of math. So how do we do it? Well, first of all, we need some data from on the isotopes. We need to know a couple of things. We need to know the abundance, and that's usually represented as a percentage, so how much of that particular isotope exists in nature. And just out of interest, this isotope of oxygen is the way more abundant one. There's 99.76 of all the oxygen found, it's this isotope. So we need abundance, which is a percentage, and we also need a mass, and that's represented in atomic mass units, which I won't explain in this video. That'll actually be in a separate video. But we use atomic mass units, or AMUs. So the calculation that you need to do, if you have 3 isotopes, so 1, 2, 3, you actually do the same calculation 3 times. And that calculation is that you take the abundance and you divide it by 100 and then you multiply by the mass. So, for example, we take 99.76, divide it by 100, that would cancel out the percentage signs, and then multiply it by the mass. And so with 3 isotopes, we'd have to do that 3 times. I actually did the math already just to save time. So with each of the isotopes, you end up with 3 values, and these numbers will go in the same order as the isotopes up here.
There it is.
Okay, so then what you'd actually do is work out do this calculation for each of the 3 isotopes, and then these 3 values would be added together to give you the average. So really, the approach that you do not want to take is to add up these 3 numbers and divide by 3, or work out the average or the mean, as give it its official name, because this one's way more abundant than the other 2. And you can compare that back to this grade analogy. If you think about maybe if responsible action was worth 10% of your grade, and trimester final was worth 90%, you wouldn't take one assignment from each category, add them together and calculate your grade that way, because of the weighted average idea. So way more exact to calculate it this way. If you add up these values, you get 15. So always use AMUs as our units. So just calculate the abundance, divide the abundance by 100%, multiply that by the mass. Do that for each of the 3 isotopes. If you have 4 isotopes, you've got to do it for that number. Add them all together and you've got your average atomic mass. And so to be correct about rounding, what we're actually going to do is go to the number of decimal places. We do some multiplication, but the last step would actually be addition. So applying that rule of adding numbers with different numbers of significant figures. If you go to the least number of decimal places in your data, which would be 2, we could just round this to 2 decimal places. So that would actually give us 16.00 AMUs. How would you know that number's correct? Well, you have your periodic table, which is easily accessible for you. You could just, compare that number to the average atomic mass on your periodic table. Quick recap. Average atomic mass, the mass of the atom, of each atom, on the periodic table is a weighted average. So it kind of depends how much of each isotope there is. A different way of saying that is the abundance. This quick calculation, you take, for each isotope, you take the abundance, divide it by 100, multiply by the mass. You end up with 3 values because you've got 3 isotopes. If you've got more isotopes or less, then you've got to do this calculation for each of those. You do the math, add them all up, round to the number of decimal places, least number of decimal places, and you've got your answer. Compare it to the periodic table just to double check your work. Quick recap of the isotope idea. Same element, same atom, looks the same, does the same job, same number of electrons and protons, so the atomic number stays the same, but the number of neutrons is different, so the mass number is different. And that's it.